we will start theorem. Okay, theorem. See, what is the theorem? If f is differentiable at a point C, then f is continuous at C. So see, how can you prove it? So prove. It is given since f is differentiable. Since f is differentiable, therefore f dash x or f dash c, not x, sorry, f dash c is equals to the limit x tends to c f of x minus f of c divided by x minus c. We can write it as f dash c equal limit fx minus fc divided by x minus c. Nice. See, when I take x equals c, then the denominator becomes 0, and if I get 0 at the denominator, then the value will be always infinity. So I cannot take x equal c. So what I will take? When x not equal c, comma, fx minus fc, the upper part can be written as fx minus fc can be written as fx minus fc divided by x minus c into x minus c. See, why I am saying this? Because if 3 can be written as 3 by 2 into 2, you know it. 3 can also be written as 3 by 4 into 4. So if I multiply and divide by the same term, then I will get the previous term only. So fx minus fc can be written as fx minus fc divided by x minus c into x minus c. Now taking limit both side, limit x tends to c. So limit x tends to c, fx minus fc divided by x minus c equal limit x minus c, x tends to c, fx minus fc divided by x minus c into x minus c. Implies limit x tends to c, fx minus fc I've written as x minus c, okay, fc equal limit x tends to c, because there are two functions, so we can separate it. Let us separate it, x minus c into limit x tends to c, x minus c. Okay, so you see again limit x tends to c, fx minus fc equal limit x tends to c. Okay, see, limit x tends to c, fx minus fc, f dash c is equals to limit fx minus fc divided by x minus c. So this part can be written as f dash c also. So f dash c into, so putting the limit, we will get this as 0, because when x equals c, then we will get this as 0. So is equals to 0. Implies limit x tends to c, fx minus limit x tends to c, fc equal 0. Implies limit x tends to c, fx equal limit x tends to c, f of c. Implies limit x tends to c, f of x equal, see, this is constant because here is no x term involved. So limit of constant is always a constant. So this is the definition of continuity. This is the definition of continuity. Therefore f is continuous. F is continuous at the point C. Okay. See, we are taking next question. Okay. Question. If a function is continuous, then it may not be differentiable. So to prove this, you must take your example. See, the example for this question is, let the function be fx equal modulus of x, which can be written as because fx can be written as two function. One is x when x greater than equal 0, other one is minus x when x less than 0. You always know it. Okay. Now see, if a function is continuous, because this function is a continuous function. Okay. So we have to prove it is not differentiable. So for not differentiable means ki a function is not differentiable only when left hand derivative is not equal to right hand derivative. So let us take the left hand derivative first. So limit left hand derivative I am taking, limit h tends to 0 f of 0 minus h minus f of 0 divided by minus h. This is the left hand derivative. Equal limit h tends to 0. Let's see. 0 minus h means, what do you know by 0 minus h? The value of x is less than 0. The value of x is less than 0. So in this function, x less than 0. What is the function? Minus x. So here the function is f of 0 minus h. So replace x by 0 minus h. Then what you will get? Minus of 0 minus h. Minus of x. X is 0 minus h. Minus f of 0 is 0 divided by minus h equal limit h tends to 0. So here you will get h because minus minus plus divided by h equal limit h tends to 0, 1, and limit of constant is a constant. Similarly, I am taking the right hand derivative. So in right hand derivative, you will get limit h tends to 0 f of 0 plus h minus f of 0 divided by h. Now 0 plus h means the value of x is greater than 0. So x greater than 0. What is the function? X. So limit h tends to 0. So here I will put 0 plus h only. Only I am replacing x by 0 plus h. Minus 0 divided by h. So what you will get here? Limit h tends to 0, h by h. Okay. Okay. Here we are getting minus h. Sorry. Here we are getting minus 1. Okay. So here we are getting 1. H tends to 0, 1 equal 1. Now see, left hand derivative we have got minus 1, right hand derivative we have got 1. Therefore, since left hand derivative not equal right hand derivative, therefore the function is not differentiable. Not differentiable at x equal 0. Okay. With this we conclude for today.